So 1.1 talked about simple interest, where you just have an amount and you get a percentage of that amount every year. So if you have $100, for example, invested, and you get 3% of it, then you're going to get $3 the first year, and then you'll get another $3 the second year, and another $3 the fourth year, and you'll just slowly build up your amount, your money, but you're always taking the interest from that initial $100. So it never changes. It's very simple. Also, it's not very common. Normally we use what's called compound interest. And compound interest is actually much more fun because you add the interest that you gained into the amount that you're taking the percentage from, so it keeps growing and growing and growing. So in the example we just talked about, if it was compound interest, $100 at 3%, then it would be $100 the first year, you get $3, you add it, so it's $103. Now it's 3% of $103, so it's just a little bit more. But you find out that as it goes, it gets bigger and bigger and bigger and becomes an exponential growth thing, which is awesome. If you're investing, not so great if you're paying on a credit card. So what we've got here in 1.2 is just your really, really basic compound interest kind of formula, where we say that the amount that you get, all of it, is equal to the principal amount that you invested times 1, which is going to bring that value of that principal forward, plus the rate that it's changing by, times time. So what we're going to do in 1.2 is just keep it really nice and simple, and we're going to just do it in a table format so we can see what happens every single time that we increase our value. So in this case, we've got $2,000 and it's being invested at 3.5%. Now, it's going to be compounded annually, they say, so each year. So that means that T is just 1. So it doesn't show up when we put it in here. We could put plus, make this big bracket, times 1, put the big bracket in there. But it just doesn't change the amount because T equals 1 in this case. And that's basically how we're going to be dealing in 1.2. So we would take our $2,000 and we would multiply it by 1.035 because 1 plus 0.035 is 1.035. So when we do that, 2,000 times, and I mean, if you've got one of these big fancy calculators, you can just, well, actually any calculator that has brackets will do it. 2,000 times bracket 1 plus 0.035, and hit your equals button, and you should get 2,070. Now that value is what you bring down here, because next year they're going to take 103.5% of 2,070, not just the same amount all the time. So then we take the 2,070 and multiply it by 1.035, because that's 1 plus 0.035, and find out what that equals. So we just keep going in our calculator. And we end up with $2,142.45. Now, if this had been simple interest, we just would have added $70 every year. But we're adding a little bit more each year, so it's going to keep getting just a little bit bigger. So that number comes over here. That's our new amount for the year that we're going to take interest from. So now I'm going to put it here and multiply it by 1.035. And we get 2217.44, round up if it's a 5 following it. And that's going to be our fourth one. They said 4 years, so we have to do this 4 times. And we get 221744. So that's the number that we're going to start our calculation with this time. Same percent rate. and multiply that by 1.035, and we're going to get $2,295.05. Yay! Okay, now remember that this is money, so you can always round off to 2 decimal places because the third decimal place doesn't mean anything. And this is going to be the final value here because we've gone through 4 years of increasing our money by 3.5%. Now remember, the rate of interest as a decimal is going to be, in this case, we would go 3.5 over 100, which gives us 0.035. You're just moving the decimal over 2 spaces. If you can remember that, it's a little faster, but people get confused when there's a decimal. So sometimes it's just easier to make sure that you've got the right one by just using your calculator and going 3.5 divided by 100, click, oh, there it is.